Hey Math 1, new video lesson coming at you, 2.11. We're talking about writing and solving equations. Still in this section, we're going to be doing geometry applications. Now it's going to be much different than what you saw in chapter 1, where we just took formulas and basically plugged in numbers. This is going to be different. This is geometry that primarily deals with angles. So, let's get to it. Number 1, find the value of A and all missing angles if we're given a triangle in which all three angles are given variable expressions. So what you guys, I'm hoping you've seen this before, where you know that all three angles inside of a triangle add up to 180 degrees. That's what's called the triangle sum. So the triangle sum means all three angles in a triangle add up to 180 degrees. So if they're asking us to determine the value of A, which is the variable that exists in each expression, and the measures of the missing angles, we just add them all up and set it equal to 180. So 3a minus 7, and I'm going to stack them vertically, plus 4a plus 3, plus 2a plus 4. These three angles added together come out to be 180 degrees. So negative 7 plus 3. You know what? I'm gonna do 3 plus 4 first. That's 7. Negative 7 plus 7 zeroes this out. So this whole column cancels to 0. 3 plus 4 plus 2 is 9a. Plus 0 equals 180. All right, divide by 9. The 9's cancel. Divide by 9 on the other side. Hopefully you guys see that 18 divided by 9 is 2. And then we've got another digit, so it's 20. And we've solved the first part of this. Now the second part, find all the measures of the missing angles. All we got to do is say, this angle here is 3a minus 7. If a is 20, I can plug in 20 for the a value right here. So this equals 3 times 20 minus 7. And I can do that with all three variable expressions. 4a plus 3, that's the same as 4 times 20 plus 3. 2a plus 4, that's the same as 2 times 20 plus 4. All right, this ends up being 60 minus 7. 60 minus 7 equals 53. So this angle right here is 53 degrees. 4 times 20 is 80. 80 plus 3 is 83 degrees. And then 2 times 20 is 40 plus 4, 44 degrees. And there you have it. There's number 1. So the triangle sum, that's a big concept. We do not have a triangle in this next one. Instead, we've got two lines that intersect, and we've got variable expressions on both sides here. Now, these represent the variable expressions for this angle and the variable expression for this angle. So just keep in mind, These represent angle measures. So what do? Well, you guys may or may not remember this, but if you take a ray and rotate it all the way around, you create 180 degrees. So this line right here can actually be described as an angle. This angle right here is a total of 180 degrees. So this angle plus that angle together give us 180 degrees. So angle 1 plus angle 2 in this case right here equals 180. Yeah, so 8x minus 3 is the first one, and 4x plus 15 is the second. So if we solve for x, then we can plug in like we did with the triangle to find the actual measures of the angles. So find x first. So 8x plus 4x, they're on the same side of the equation, so you just combine them as they are, is 12x. Negative 3 plus 15 is a positive 12, and that equals 180. All right, we're left with an equation that we saw back in section 2.1. Minus the 12 from both sides. 12x equals, this ends up being 168. Divide by 12. And you might have to go off to the side and figure this out. You can actually cut 168 and 12 in half. Half of 160 is 80, and half of 8 is 4, so it's 84. Half of 12 is 6. Half of 84 is 42. Half of 6 is 3. And that's just an easier number to compute. It's 14. X equals 14. So now what we do at the very end is we take our variable expressions that exist here and here. Maybe I'll write that off to the side. Yeah, I got some room. 8x minus 3 is the same as 8 times 14 minus 3. And 4x plus 15 is the same as 4 times 14 plus 15. So you can go off to the side to do those calculations. 14 times 8 ends up being 32. Carry the 3. 112 minus 3, that ends up being 109. So this is 109 degrees. Here, 4 times 14, I have that committed to memory. I know it's 56. And then this will be 66, plus 5 more is 71. So 71 is the other angle. Right, two angles that add up to 180 degrees have a special term. It's called supplementary. So you might want to write this on your notes somewhere. Two angles that add up to 180 degrees are supplementary angles. All right, number 3 is a little bit different. We still have the 180-degree action happening over the span of this entire line. However, we can do something slightly different in this particular case. That little box like there indicates that a right angle is formed from these two, they're called rays, intersecting. So, if this is 90 degrees and the whole thing is 180, then that means that this also has to be 90 degrees. Angles that add up to 90 degrees are called complementary angles. So these 3 angles add up to these 3 angles add up to 90 degrees. It's like this is a giant right angle. So what I'm going to do is I'm going to say 3b minus 10, my first one, plus b plus 5. All 3 of those angles should add up to 90 degrees. And then I just do what I did on the first situation, where we just combine the like terms. 3 plus 1 plus 1 is 5b. Negative 10 plus 5, opposites subtract. 5, take the sign of the bigger one, and then solve it like you would solve an easy one. Add 5 to both sides. Divide by 5. So B ends up being 19. Just to confirm that. Put the 95 in the box, the 5 on the outside. 5 goes into 9 one time, multiply them, subtract, drop down the 5. 5 goes into 45 9 times exactly. Okay. So now we plug our 19 wherever we see a B. So this angle right here is literally 19 degrees. This angle is 19 plus 5. So 19 plus 5 is 24 degrees. And here's an alternate way of solving for the last angle. If we know that these 3 have to add up to 90 degrees, you could just take 90 minus 19 minus 24. So that's almost taking away 20. Taking away 20 would give you 70, so it's 71. Take away 24. 11 minus 4 is 7. It's 47 degrees. I just wanted to share with you guys that there is an alternate approach. Instead of just plugging the B in for, or the 19 in for B right there, you could do it that way as well. All right, this seems like a good stopping point for the video. I'll show you guys examples 4, 5, and 6 in the next one.